Hey guys, welcome back to the Tic Tac Toe Part 2 episode. So, in this episode, we are gonna check into how we can make an computer move. So, we can call it as AI move, and then we can play against the AI and then see if we can win or not. So far, we have done is like we have made the reset button work, and then one of the player can start with the X value, and then the next player can start with the O value, and then we can continue playing. So that's it. If one of them wins, we will get a message saying that okay, player O wins. So if none of them actually wins, then we will get player, the game is actually in a draw, right? So we can do that now. Check. Okay, and then so yeah, it's a draw. So that part is working. So let's get into setting up a make AI move. So for that we should write a function, but before that we should check conditions. Like we should check if the game is actually active. Only then we can do the AI moves, right? So if game equal to active, and then the current player is actually O. So I'm going to consider O as the AI element over here. So that's our AI partner. So I'm checking if game is active and then the current player equal to O. So what happens is in the beginning, the X will set up the X value, right? Then we are using a toggle player. We are calling the toggle player function, which will actually change the value to X to O. So that after that we can check, okay, if game equal to active and then the current player is equal to O, then we can call our AI move, right? So I'm gonna set a flag also saying that it is actually AI's turn, and then I'm gonna set it to true. So in the beginning I will also define it over here. Let's saying that let AI turn is false. Okay, and then we can make use of that flag in some certain places. Okay, so now we have set up the AI turn flag as true, and then we will give it a little bit of timeout to make the game flow a little bit smoother. So set timeout, make the AI move. Okay, AI move, and then it's 500 milliseconds. So it's not that much of noticeable. So inside that function, what we can do is like we will check if function to write AI move. Okay, so function make AI move. We'll check if that AI turn flag is actually set to true. Then only we need to execute this, right? So if AI turn equal to true, then we can do a make random move. So in this way, the AI will generally make a random move saying that okay, like a function to make a random move, and then function make random move. Okay, and then const available, we will create an empty array for the available moves we have at hand so that AI will know which move to actually execute, right? And then for let I equal to 0, I less than board dot length. So the board is the same array we have created in the beginning itself. So this board is the array we created by multiplying the grid size. So now we have it, and then we are going to do I plus plus, and inside the for loop, what we'll check is if board of this particular index is equal to empty, then we can set that okay, const available moves, available moves dot push that particular index. So now we have our available moves listed in it. Now we can say we can pick one of the random index from that particular array we have created, right? So from the available moves, so we can make use of the math library. So math dot floor and then math dot random. So we are going to randomly pick a number from this available moves, and then we are going to floor it. So it will give you the nearest and the lowest whole number with the random value. Okay, and then we can call our function for place symbol, and then we will say available moves and then random index. So what this does is we have this available moves array. So we are going to get a random index and then we will send that particular random index value into the play symbol function. So what play symbol does is it will get this particular index and then based on the current player it will execute it and then it will draw it. All right, so let's check if that part is working. So we have this one. So yeah, I made the move. All right, so randomly it's making, so it's easier to win. So anyway, it's an easy difficulty mode, so it's like it's normal, right? So we can win. So now we need to make sure that this, as the difficulty changes, we need to also include the logic for the AI move, right? So for that, instead of directly making the random move, we can check if the set difficulty is equal to easy. Then we can use make random moves because that makes sense, right? So the AI we can actually play casually. So let's say if the difficulty is actually in medium mode, then we will throw a dice. Like let's say one chance, like 2 in 1 chance is actually gonna be an obstructing move. Otherwise, we can just do like a random move. So for that, we will again use the math.random function. So math.random, and then we will check if random is less than 0.5. So it's a 50-50 chance, right? So we will call make random move. Make random move. Else, we will create another function for make obstructing move. So basically what obstructing move does is we can create a function for it to say that, okay, if you have selected this particular value, and then when you select the next one, what AI will look for is like, okay, what is the next steps which are available to the player so that the player will win. So if in this case, this one is the winning cell, right? So the AI will put his mark over here if you call make obstructing move. But if you have multiple conditions, but anyway, there are chances in which you can get multiple conditions for the win, then AI will be only able to put one over here and then you can win. So in this particular scenario, I'm going to check if the random value is greater than 5, greater than 0.5, then I can call make obstructing move. Otherwise, it's a random move. Okay. And then else if difficulty equal to hard, right? Then we can directly call the make obstructing move. So once this is done, we have to make sure that we will turn off that particular AI mode, right? So let's say false, and then we can create the function for obstructing move. So for that function to create obstructing move from AI, okay, function make obstructing move, and then inside that we will go through all the combinations we have so far at our hand, right? The winning combination. So let combination of winning combinations, and then inside each combination we will use our ES6 destructuring from each of the combination. So what we have at hand is like our combination is actually in the row case. We remember, if you remember our combination creation section, we have used row value 0 1 2. So we are going to take a into, like, if it's an array of 0 1 2, then the eighth value will be 0 and then the bth value will be 1 and then cth value will be 2. So this is necessarily what array destructuring means, and it was introduced in ES6. So if you want to know more about this, I will put up a short soon, then you can check that out. All right, so then what we are going to do is we are going to check if any of this index is actually equal to the player X. So if board of A equal to X, and then we will also check if board of B equal to X, and board of C equal to empty value, right? So this is one condition that can happen. And then the next one would be board of A equal to X, and then board of B equal to empty, and then board of C equal to X. This is the second condition that can happen, right? So I have put this and then another bracket, and then if that's the case, second condition is done, and the third condition. So second condition, third condition, for that we will also check if board of A equal to empty, and then board of B equal to X, and then board of C equal to X. So basically we have three conditions. One condition is we are checking if Ath and Bth index are equal to X, and then Cth index is equal to empty, then that's where we need to put the Cth index is where we need to put the O value. So if board of A equal to X, and then B equal to empty, and then C equal to X, then Bth index is where we need to put. And then same wise, the next condition is A is empty, and then B and C are filled. All right. So in that case, what we will do is we'll check another if condition saying that if board of A equal to empty, then we will put in the eighth index. So we'll say place symbol at the A index. Okay. So we will do the same thing for the B index and then C index. So board of B equal to empty, then we will use place symbol of B. Okay. And then else if, or it's going to be there are only three conditions satisfied, so we will call place symbol of C directly. Okay. And then if this is done, we can just return from the function, because like we have used the AA mode, and then we can just directly go back. So if there are certain scenarios in which none of this condition will happen, right? So in the beginning, the game in here, none of the conditions we have written over here is actually matching. So only one condition is there. So in those cases, we will directly just make a random move, to handle that particular situations as like moves, because like we don't do anything else. There is nothing actually obstructing the user. So we will directly make a make random move function. So this can help with it, right? Let's check. Okay. So it's randomly making, so the player X wins. Let's see, let's directly go to hard mode. So in the scenario we have change difficulty is not defined. So did we change the difficulty? Index 15. Okay. So and here index 15 on change. Okay. So here we have set up a on change difficulty function, which we haven't written yet. So that's why we can't change the difficulty mode. So we have to write that particular function. So function to change difficulty mode, right? So function change difficulty. I hope that's the correct spelling. I'm gonna copy it. Okay. Change difficulty in here. What we will do is we will just set the difficulty to the value of that particular select value. So difficulty equal to document dot get element by id. It has an id of difficulty, right? So we will say select difficulty dot value. Okay. So now it should allow us to change the difficulty settings. Let's go back to hard, and then let's do okay. So if you notice, it's directly put the element over here. So if you put over here, it check for the first condition, which like it follows the rows, and then it check for the column. So column condition actually satisfied. So we were able to like block the column condition, successful condition. But as for the diagonal one, it wasn't able to. So we can win with the diagonal one. So the hard condition is working as expected. So let's check in medium, and then medium. So yeah, it has a 50-50 chance, right? So one time it did a random move, and the next one it did a obstructing move, and then this one also did an obstructing move. So here this one also did an obstructing move. So our luck is bad. Next one, let's try, and then this one. Nice. With this one, yeah, so we have two modes, like two winning positions, but it chose to go on the random section. So yeah, we win. So all of these conditions are working. Now we just have to look at how we can change the grid value, right? So for that, we also have selected a function over here saying that change grid size. So we will just write out that function to change the grid size. Function change grid size. And then here also we just need to update the value which we have created over here, saying that okay, grid size equal to 3, right? So instead of that, we will get the value from the select element over here. So if you notice, select element value is 345. So we can say grid size equal to document dot get element by id. The id is grid size. So I'm going to copy it over here and then dot value. Okay. And then we have to recalculate the winning combinations for this. So we will again call this one winning combinations and then grid size. Okay, now we have the winning combinations. Now we just need to make sure that we have reset the game. Okay, so this should give us the entirety of the game. Let's check. Yeah, so we have 4x4. We can check easy mode. So yes, so easy mode, it's working, but it's still not have won the game. So there is something missing over here. So I figured out the issue. I think it's because the value we are getting from the grid size is actually a string. So in case of string, when you go to the calculating section over here, let's say in our const diagonal section, if you do console.log I into size, I was trying to see how the size was calculated. And then if you notice, when you go to 4x4, you are actually getting a string. So what JavaScript does is, if it's a string with an integer, it combines them. So it's not calculating it, it's actually combining them. 4 plus 1 is actually doing 41 instead of it should be 5, but it's giving us 41, right? So here 4 into 2, it's actually giving us 83. So that's so on and so forth. So what we have to do to get rid of this problem is, when you change the size, you just make sure that you're converting it into parse int. So this should take care of our issue. Let's say here, and here, yeah, player expense. So let's making sure that our winning combinations are same. So if you go through over here, we have 0 1 2 3, which is 0 1 2 3, and then 4 5 6 7 8 9 10 11 12 13 14 15, and then the next one will be 0 4 8 12, and then 1 5 9 13, and then 2 6 10 14, and then 3 7 11 15. All right, so that's done. And then 0 5 10 and then 15, so that's also correct. Then 3 6 and then 9 and then 12. Okay, that's also correct. So that part is done. And then even if you change it back to 5x5, I think we can get it. So let's check winning combinations. Yeah, so we have, yeah, so it's expected. All right, so let's check if we can win the 5x5 one. Okay, so let's try here and then here. Yeah, so yeah, in AC mode we can absolutely win, but I'm not sure about the medium or hard mode. So all right guys, that's it for our tic-tac-toe game. If you have any comments or questions about this particular tutorial, just let me know in the comments, and I will address it to you guys as soon as possible. Or if you want to build any app or game that you have in your mind or you want help with, just let me know, then I can do the same as well. So until then, keep coding. I'll see you guys in another one.